So I just thought I'll take a moment or two to look over some of these exercises that I've been working on recently. I've done a few more, but I haven't really committed them or added them to the actual repository. But it's basically some Golang there, which are just walkthroughs and things of that nature. And there's also some Erlang code. I wanted to go over the Erlang code particularly because it's the one that I thought I found a bit more interesting and a bit more challenging, just in relation to how it works, and things of that nature. So just sort of wanted to just discuss that a little bit here. And so as you can see here, you get your module definition where you define the name of the module, and then here you define what functions can be exported using the actual module. So for example, as you can see here, you define a list, and where there's a list there, you define the arity. I don't know how to say it properly, but I not really understand what it means. But basically, it's the number of parameters a function can take. So you can have one function, same name, but it does multiple different things because it can take input in a multiple different fashion. So here I was looking at the exception section. Which is basically pretty straightforward. Just looking at the code here, we can sort of see, there's the throws function here, which demonstrates what happens when there's a particular error. So here what we're actually doing is we're actually defining various inputs, right? So there's a try catch basically, and in the try catch here we try catch either a throw or an error and return that with a custom error. So here's basically defining what appears to me to be definitions of custom exceptions. From my point of view of things here, this function here made it a bit more difficult for me to grasp what was going on, because what it's doing is it's actually doing quite a number of different things, and I don't know, I can't formulate in my head as to how this actually, I understand what's happening in some of these sections here, but I'm not too sure as to how the actual events happen here in one sense or another. But here, as we can see, we have the different attacks that can be carried out with the sword. And here we catch the different errors that can occur. It's basically my understanding of things. And this code is very bizarre because it's actually quite difficult to read in itself. Just in general, just like contemplating it. But as you can see, we have like a function, and the function returns something. If the function ends with a dot there, so if I had like a code runner, I could run this code here to sort of demonstrate how it works. But as you can see here, we sort of put in, so exit will take cut leg, and then here, you know, if whatever attack is based on whatever function we feed it, it should return to us an error. So it's either going to be one of these things here, or it's going to be one of these things here. So for example, if you use the function if you use the function talk, you should just say none shall pass here in essence. And if you use a function such as sword 1 or sword 2 or sword 3 or whatever the case may be to define a particular attack, and if that attack is actually caught here, then it should return that in essence, and basically depending on whatever error is returned from that, the particular message here should be what is basically returned by the catch. So it will execute this particular function or whatever code that's following that. So basically this is what a try catch looks like, which is kind of weird. This bit here was a bit difficult for me to understand, this section here, just because of the way that the functions was formulated. This here, all it does is it pretty much takes a list of sequence 1 to 100, and for each of those it times it by 2 and creates a new list. Basically, I believe it creates a new list, it basically returns the output, but this always returns tequila, which always returns, you know, this at the end of the day rather than a code expression. But I think if any one of these here fails for a specified reason, then it might actually catch that. Was most of the time it comes back with tequila there. Like for example here, as you see, this one here won't actually do anything. That won't return no error. The throw will get basically ignored, with my understanding. Yeah, no, I don't think it'll. Yeah, no, I don't think that it'll have to be something in the lines of, because the tuple here doesn't really look the same as this. But yeah, I think that's probably one thing that I'll probably have to just look over this one here to get a better understanding of later on down the line. Here we see the catcher function, and basically here what we're doing is we're actually causing an error, but we supply to like something like a value that can't be divided in this manner, and then here what we're actually doing is we know what we will get, and what we do is here we actually catch that, or otherwise we return whatever it is that we're actually expecting to return, or whatever value that we actually get from that particular division. But normally, you know, what you'd actually do is you'd actually have these tuples there, and then what you can do is you can actually pattern match on those. So the exceptions are a bit actually quite iffy, but I hope that sort of made some sense. Like I think if we look at functions here, you can see here that, for example, you know, this sort of makes sense, because if, you know, if x equals x, if these two values match, then return true. Anything else would be false, basically. I hope that makes some sense. So basically it runs the function twice, and you know, you want to check to see if the values are the same, so you just put the same variable there twice, and what it does is it matches the right hand side. So these variables have to be equal regardless for it to match, and it won't match if it's anything else. Well, these underscore means that it just skips it. And as you can see here, it's just basically how to define functions. Here, this is the head and the tail. So this returns the newest value. So you can actually do funky things with that. In relation to that, this one here returns the second value in a list. So you actually take a list and you can return either the second value, like extract the second value from it, or go get the first value, which is what these two functions here do. And these ones here, checks the time and the date, but I can't remember as to how it actually gets the correct time and date, because I don't think this tuple here, unless this tuple here holds this value here holds the actual correct time, and this one here holds the actual correct date. And basically you match on those values there to say year, month, and date, and they have to match whatever this tuple here has been defined as and whatever this tuple here has been defined as. But again, at the same time, as I'm saying, I don't know if that can be dynamically updated in the background. Maybe you can do that using some other type of function. To actually do that particular lookup or that matching process there. So as you can see here, these just print the characters and the values there. So yeah, so that's pretty much that on pattern matching. Anything that doesn't match this particular format won't get passed in. So yes, actually maybe rather this doesn't actually check to see if the date is valid, but it takes in any time and date tuples to actually compose what actually becomes the values that are printed here, rather than actually comparing it to an actual value of the date itself. And the IO format is basically just a print there, same as a print function, and basically that's how that pretty much functions. Records are a bit different. As you can see here, records, you define a record of a robot, and that take me ages to, so basically here you can include records. You can see here, and these can then get imported into the overall function. And basically you just define these, and then you can basically use them. So you define the record robot here, and then as you can see here, you can use it in a function however way you see fit by adding information. So here we add extra information to the list. Here we define a type. So this actually becomes a custom type. Car factory. So where's this record here actually defined? Was that the one actually defined in the... No, there's another actual one defined in the... I'm not sure if you can actually dynamically define those. And basically here we define a user record, and we create a function that can then perform various aspects or various matches on that actual record itself, to make sure that, for example, that anyone who can access the admin panel, they have to have this value set in that particular record for it to be valid, for them to actually use the admin panel function, which is pretty cool. And here also you can do various checks and things of that nature, which is also pretty interesting. So as you can see, the language itself is actually quite banal, to say the least. Like I'm not say you match here on the actual language itself, and here is where we actually use the included value from the records section. But here we sort of access various fields within the record, and we update the record by creating a new value. So the data itself is actually immutable, so we create the new values for that. But here we're actually updating the value from the okay, so here the actual detail section here is going to be blank, or we can pass in a field. So we can actually pass in this function here and return this into the robot field as Rob, and then we can access details to see these particular details here. And then once we have those details, we can then proceed onwards to actually update those and return a new value. So that's pretty much records in a nutshell. They look a bit weird, but that's pretty much what they are and what they particularly look like, and they're pretty useful for a number of different things. You know, defining structs. They don't look very nice, but at the same time, you know, it is what it is. And this one here is basically a function that uses trees. I'm not gonna to create a tree or to create like a graph node key of higher or less. I think, you know, before conclude here, I think one thing would be covenant functions. Covenant function. I think that one of the cool things here to actually conclude on would be the gods. Let's use this here. Because this is just an initial example of how the functions work, how comments work. Hello. And here, for example, you know, we take the value x, and that gets set to thing, and this is what basically gets returned. So this prints IO hello world, and adds whatever value x is given to this function to 2, because that's what gets passed into this particular function here. That's pretty much that. I think one of the cool things to look at just for today would be gods. So gods are pretty interesting because they actually allow you to do cool things, such as check, as in, you know, take the value age as x and say that when this is like this equals 16, greater than 16, then match that and say that's true, that's old enough, else anything else is false, right? Which is pretty cool. And you can comment those as many times as you want. So you can say the right age is when x, which is the value that's passed in for age, and this could actually be matched against a field. You know, you say when x, so for example, you know, just say for example here in records, just as we pass in the record Rob here and then access the details there to utilize any one of those actual functions, just like as we do here. You know, you can say rob.robot.age or whatever the case may be, and pass that into the function, and then have other functions that then actually make use of that. And so here, when we say the right age x, when x is greater than 16 but less than 104, that's true, else anything else is false. So if it doesn't match here, then it's something else, and it would be invalid as false. You know, or you can do things such as an inverted check, where he checks if it's less than 16 or greater than this value, then that's true, it's the wrong age, or else it's the false age. So you can check right age and false age, and basically choosing which one is better for you in that particular instance is dependent on your actual environment and the application that you're writing and that type of thing. But basically that's how to do that. Gods are very interesting, and you can do that for a number of different things. You can check on the type of data, you can check on the type of value, but you shouldn't have to do that to enforce type checking or whatever the case may be. Types should generally be okay in Erlang, like it can handle that type of stuff for my general opinion. But yeah, that's pretty much that, which I think is pretty cool. So guards can be utilized in a number of different things, and you can use it to just say to define a function based on the type of input data that you get and how to operate in that particular data itself. There's a couple of other functions here that I'm not actually going to go into at the moment. This one here is like things like, for example, add 1 to every single. This is pretty interesting. So you can have functions that return numbers, right? So here you can put 1 and 2 as functions and use them and add, and then that gives you the number 3, right? If you do this, you get the number 3. You put 1 and 2 into this function, and then you get the number 3. Here you can do increments. Well, you can increment every value in a list. So basically this is like basic recursion. And basically you take the head and the tail. The tail is everything else in the list. The head is the value most immediate in the list, and you add 1 to it. That's pretty much that. But you could do like something like here you might get like an error. For example, if someone has a letter in there, but every single string value is a list at the end of the day, but and sometimes it can be interpreted differently. But basically anyway, here what you're doing is you're basically doing this until you reach the end of the list when there's nothing left. So basically you do add 1. Damn, I'm 22 minutes already. I think the way that I talk is actually not quite, because I feel like I could have definitely done this in a little less time than the amount of time that I've actually utilized at present, which is quite bad for my opinion on things. But I just finished up here, which is head add 1 increment t, which is the tail. So that takes a new value at the top until basically there's nothing left in the list. And I think what you end up with is actually a return of the new list, because each time you do this it creates a new list, which then at the end of it you add up with a list of each value that has been added up, that has with each value in the list added up to 1. And decrement is basically the same thing as you can see here. All you do is change the -1 there, and then you end up with an empty list there, and basically when that matches it basically returns it basically completes. So at least if you get like an empty list, it won't do anything in essence. It pretty much just completes the function there, and you end up with a list that has each value in it has been decremented by 1. And here you have a map function which does something. So it takes a function, and whatever the function does for a particular number, it takes that and then does whatever that operation is, right? So if it's something like increment or decrement, you can put that in the map function here, and then it does everything for that particular value in the list, which is pretty interesting in one sense or another. It's actually pretty cool in one regard. So that's one thing that you can do there with higher order functions. It really just helps you operate or work on data in really efficient and cool ways, especially when you've got lists of functions, whether be it that the actual list themselves are structs or tuples or whatever the case may be. It just enables you to operate on that data in the most efficient fashion possible, which is really cool. So I think next time what I might try to do, I might try actually get run these things that I've went over, these functions that I've went over, and just run the examples on in an Erlang repo. There's some Go stuff here which I can go over another time, but nothing too serious. I think the coolest thing will probably be the channels, which basically creates like a buffer. You know, there's buffer channels and non buffer channels, but the channels are pretty interesting because they just allow you to process data in the most efficient way. And you know, in this instance here, you'll be using Go threads to run, or at least, what are the name of functions? Is it Go threads? They're not really Go threads because they're not the same as Erlang threads. I'm not sure what the term for it in Golang is, but it's basically, you know, you spawn if you use Go here, and then the name of the function, and then C, which is the channel, and then here you do a for range in the channel. Whereas this one here, I believe it'll be static, so it'll take each of these values and pretty much just run it. So here you do a for range on A, this is A, and A goes into each one of these channels, and the C goes into num, and that gets printed. And if for num is greater than or equal to 0, pretty much print that number in essence with the channel there. It looks a bit weird here because this is set to 0 by default, so you wonder if this is actually going to run or not. But as you can see here, the C there updates that value, and as that channel is updated, I believe that it actually performs a print, and then here it just ends the main function. So here, Go threads, is it? I need to double check some of the Go stuff, or at least, but I'm pretty familiar with it. Like the coolest thing would be the Go routine. That's it. Yeah, so we'll go over that some other time there. But there's definitely all sorts of interesting stuff when it comes to the Go stuff. These things such as weight groups. Yeah, it's Go routine. You also have like these anonymous functions here, and basically different ways to schedule that onto the program. There's a bunch of different things in Golang, so we can go over that at a different time, just to see how cool that is, or at least how interesting it is in essence. And that's pretty much that. Really, just sort of go over that. Hopefully, it take a little bit longer, and I don't know why it seems like speech, or maybe it's like I probably just left it a little too late to actually do the video. But yeah, that's pretty much that which I wanted to cover in essence.